Hello everyone, welcome back to my YouTube channel. So in this video we are going to discuss about Kubernetes Network Policies. So let's understand in more details. So what happens in Kubernetes when you deploy any Kubernetes pods, they can communicate with each other without any restrictions. But if you're working on production environment or in a real-time environment, then you don't want to allow all the traffic between all the pods. Suppose you won't allow only backend pod can communicate to with your DB tier, and you don't want to communicate your front end pod directly to your DB tier. In that case, how you will restrict the traffic? So to achieve this, we generally use a network policies. So there are two networks policies, ingress and egress. So ingress basically incoming traffic and egress means outgoing traffic. So let's understand with this image basically. So suppose I have here two tier, front end and back end. So I have one pod in front end and another pod in back end. Now if we don't have any network policies in our environment, then these two pods can communicate with each other. But if we will allow, or if we will implement some kind of network policies, in that case, until we will not explicitly allow the communication, these pods cannot communicate with each other. So what we are going to see as part of this video, first we are going to implement a communication between front end and back end without network policies. Then we will implement a network policies, and then we will see the difference. So as I told you, there are two network policies. The very first is egress. It means outgoing traffic, means from this particular application pod the traffic is going out. And another kind of network policy we have is ingress. So in ingress, the basically incoming traffic. So on this particular application pod, the traffic is incoming or coming from the backend pod. So these are the two policies generally we implement to restrict the traffic or to restrict the communication between application pod. Either it could be in different namespaces, or you can have in a default namespace as well. So as part of this demo, we are going to create both the pods, front end and back end, in our default workspace, namespace. So let's do one thing. Let's implement this communication, the first part basically of this video. Then we will try to implement a network policies, and then we will see how we can explicitly allow the traffic, for example front end to back end or back end to front end. So to achieve this, let me go to my Visual Studio Code. And before that, one more thing. So as we know, in this whole series we have used a Docker desktop. So in Docker desktop, let me open a Docker desktop. So this is the Docker desktop which I am using, and here I am using Kubernetes cluster as a kind. What there is a one issue here. The kind by default use a CNI plugin which is kindnet, and kindnet doesn't support network policies. So for that, what we have to do, we have to use, or we have to create a Calico or Cilium, those kind of CNIs. Then only we can achieve network policies demonstration as part of this video. So what we are going to do, let me quickly open my Visual Studio Code. So if I'll simply type here kubectl get pods, let me do -a, sorry. So you can see as of now we have a kindnet, which is default CNI which we will get as part of our kind Kubernetes cluster, but this kindnet doesn't support network policies. So we need to disable this kindnet, and we need to install a Cilium or maybe a Calico we will install, so we can use or we can implement the network policies as part of this demonstration. So what I'm going to do, first I'm going to delete this Kubernetes cluster, and then I will recreate this Kubernetes cluster with this configuration. So here what I'm going to do, I'm going to disable default CNI, which is true flag. So the instead of kindnet we will use a Calico. So let me do one thing. Let me first delete this Kubernetes cluster. So for that I'm going to use kind. So I have kind.exe in my current location where I am. So let me clear the screen and let me delete the cluster first. Okay, so if I will do kubectl get pods -a, okay, still we are getting, it means it's not deleted yet. So let me clear the screen. Okay, so now what I will do, let's verify again. Okay, still it's running. So let me clear the screen first. Okay, let me apply this configuration. Sorry, not this one. So kubectl create. Okay, let me copy the command. I have already copied in my GitHub page. Okay, so we have to use kind, not kubectl. So let me clear this screen. Okay, so this is not recognized. So let me do one thing. Let me put here dot slash. Okay, so it is going to create a kind Kubernetes cluster again, and it is going to disable the default CNI. So we will not get a kind net. So let's wait couple of minutes. Meantime, this cluster is getting created. Okay, so the cluster has been created successfully. Let's verify it with this command. Okay, so control pane is running, code DNS is also running, that's fine. Now let's do one thing, let's verify the ports again. So now you can see we don't have a kind net, which is default CNI. So now what we will do, we need some kind of network plugin so we can implement network policies and networking in our Kubernetes clusters. So we are going to use Calico. So what we are going to do, we have to simply run this command and it will install a Calico CNI. So let me clear the screen and let me run this command. Okay, so Calico is successfully installed. Now we have a container network interface, which is Calico in this case. Because KindNet network interface or KindNet CNI doesn't support network policies, that's why we have installed a Calico and we have disabled the KindNet. So let me clear the screen. Let me verify the ports again. So now here you can see the Calico Cube controller, which is in pending state, and we have another one which is Calico-node and some random numbers. So the status is initializing. So let's wait couple of minutes. Meantime, these two pods will be ready. Okay, let's verify the status again. Okay, so still we are seeing containers creating. So the Calico node 1 is in running state, but it is 0 out of 1. So I think it will take couple of more minutes. So let's wait. Once the status will be running and the ready state will be 1 out of 1, it means the application pod is running successfully. Let me clear the screen as well. Let me rerun the command. Okay, so still we can see two containers is in creating state. Let's wait couple of minutes. Okay, so now we have all the pods up and running. You can see the ready state, which is 1 out of 1, and the status is running. So now the Calico CNI is successfully installed and running also. To verify it, we have a command for that also. So let's copy this. So basically again we are going to check the status of pods, which we have already verified, so it's fine. We will leave this command, it is not required. So now let me clear the screen. Now what we will do, we will let me go back to my presentation. So first we will deploy front end and back end here. So for that, let me copy the content of front end. So here let me explain you this. This is a simple deployment which we are going to create. So API version which we generally use for deployment, which is app/v1. Kind is deployment. This is the name of our deployment. We are going to label this deployment, which is app colon front end. And we want a single replicas of this deployment. So we have mentioned here replicas colon 1. And this is the selectors, and this is the template, and this is the specification of container. So we are going to use a nginx container image, and here we are also going to create a service which basically allow us to access the nginx applications. So basically we are going to use a cluster IP here. So now let me go and create this file. Let me create a new file, frontend.ml, and let me copy the content. You can see we are getting some warnings here because we have not specified a resource block here. That's why we are getting these warnings, so we can avoid it. So now let me apply this file, kubectl apply -f front end. Okay, so it will create a deployment, front end deployment, and a front end service as well. Similarly, we will do for our backend as well. So again, let me copy the content of backend. So again, this is the same content here. Just I have renamed it, like instead of front end, I have mentioned here backend, and label also we have changed. Okay, now let me apply this file as well. Okay, so this is completed. Now we should have a two pod is running and two services. So let's verify kubectl get pods. So we have front end and back end is running. Let's verify the services as well. Okay, so we have two services, front end and back end. Now what we will do, we will curl from the because as we know the nginx is listed on port 80, which is we have specified here as well. So on port 80 we will do a curl from the front end, so we should able to see a nginx home page. So for this let me go to my documentation. So here let me copy the command. Sorry, not this one, this one. So here you can see we are going to use kubectl exec-it, and this is the deployment deploy/front end. So this is the name which we have given to a service, and front end name is, sorry, a backend name, service name is backend. So now let me copy it and run it. So here you can see that we get a response, welcome to nginx. So this is the home page of our nginx web application. So it means we are going to or we can say these two, front end pod and back end pod, can communicate with each other without any issue. Now when we want to restrict the traffic, then we have to implement the network policies. So for that, what we will do, let me go back to my diagram. So here this part next we are going to implement. So we are going to basically deny all the ingress and egress traffic between both the pods, so they cannot communicate with each other. Before that, what we have to also do, we have to allow the DNS, because when we will allow a front end to back end, this particular part, in that case the name, the front end and the back end name basically should be resolved, like the because the use of DNS is to resolve the name to a IP or IP to a name, sorry. So in that case, what we will do, we should allow a DNS so it can resolve a backend traffic when we will do a part 4. So for this, what we will do, or we can do one more thing. First we will deny the traffic, then we will allow the DNS. Let's see if that works. So first what we will do, we will deny all the traffic. Okay, so let me create a file here. Okay, so let me go to my VS Code here and let me create a file deny-all.ml. So basically here what we are going to do, we are going to restrict all the ingress and egress traffic between both the pods. So if I'll go back to my file here, which is deny all. So here what we are going to do, so we are going to, so this is the general like API version networking.k8.io/slash p1 and kind is network policies, which we are, because this is the resource which we are going to create. Under metadata, this is the name of our policies and the namespace is default. So this policy will be applied to a default namespace. And as we know, we have created our front end and back end in a default namespace. And under specification, we have defined a pod selector. So basically this is the empty pod selector. So if you can see these brackets, it means this is the empty pod selectors, which basically select all the pods in the default namespace where we are going to apply these policies. So for example, we have deployed only 2 application pod, front end and back end. Maybe we have few more application pod. Then if we will apply pod selectors as a empty, then all the new pods which we are going to create in a default namespace, they can also not communicate with each other because of deny all policies. So here we have defined a policy type -ingress and -egress. So this policy basically enforce all the incoming traffic, restrict all the incoming traffic, and this will restrict all the outgoing traffic. And this is the empty string, meaning no incoming traffic is allowed, and egress is also empty list, so it means no outgoing traffic is allowed. So this is the policy which we are going to apply. So let me copy the content and let me save it. So now let me clear the screen and let me apply this policy kubectl apply -f deny all high.ml. Okay, so spelling mistake, let me correct it. So this policies has been created. Now what we will do, let me clear the screen. Now I will again do the curl from the front end to a back end on port 80. Earlier we will used to see a HTML response or the default homepage of NGINX application. Now we will see if we are able to get the response or not. So let me run this command. So it will take couple of minutes, it will hang or it will give some warnings like can't reach or cannot communicate something, because we have restrict all the incoming and outgoing traffic between both the pods. Actually we have not specified any pods here, we have used a pod selector. So all the pods between all the pods in the default namespace cannot communicate with each other because of these empty list. So you can see could not resolve host backend command terminated with exit code 0. So you can see the could not resolve host backend. That's why if I'll go back here, so that's why I have mentioned here step 2, this one allow DNS. So at least it can resolve the DNS name, then it will tell us okay, I'm not able to communicate from front end to a back end. That's why deny network policies I have kept it at number 3. So okay, let's do one thing. We will allow a DNS, because that is required, because the front end request will go to a core DNS, then it will go to a backend. So at least the name resolution should happen. But because we don't want to restrict the name resolution, we want to restrict the network traffic between both the pods. So for that we are going to allow the egress traffic using this particular manifest file. So let me create a file first. And here you can see policy type we are going to use egress. So, and this is the list of allowed egress rules. So two name selectors, namespace selectors, empty we have kept here because we are targeting all the namespaces here. This is the match label. So this is the system. This is the namespace. So this is the match label k8-apps colon cube DNS. So this is the target, like the DNS pod will be running with this label. So if anything match with this label, they can basically egress traffic will be allowed on that. So let me copy the content. Okay, so there is some issue. Okay, let me take a content from this file. Okay, so let me copy the content here. Okay, it's fine now. Some indentation issue basically. I don't want to waste the time to fix this indentation. So now what I will do, I will again apply the file kubectl apply -f and allow. Okay, so this is completed. Actually this step we should execute at number 2 because we have already denied everything. I'm not sure if that work or not, but let's see. So now what I will do again, I will again do a curl from front end to a back end. Now let's see if we are able to resolve the error of name cannot resolve. So let's wait a couple of seconds. Okay, so now we can see earlier we were getting error name not resolved. So that error basically we were getting because we have not allowed the DNS traffic, because we have completely blocked all the incoming and outgoing traffic. But now we have allowed the DNS traffic. So now we are getting an error, failed to connect to the backend port 80 after this milliseconds, could not connect to the server. So this is the exact thing which we generally want when we apply deny all policies, because we have denied all the incoming and outgoing traffic between both the pods. So this is fine and this is expected. Now what we will do next, let me close all these files and let me go back to my diagram. So we have completed first, second and third part. First we have allowed the traffic between both the pods without any network policies. Then we have applied, or then we have basically denied all the traffic between both the pods because we have denied all the ingress and egress traffic. Then we have applied only DNS traffic because we needed to resolve a name. Now next thing what we will do, we will allow a traffic from front end to a back end. So now let me go back to my file. Sorry, not here. Allow front end to back end. So here basically what we are going to achieve, we are going to allow a traffic from front end to a back end. So the pods can front end pods can communicate to a back end pod. So here we are going to allow a ingress traffic basically. So here you can see the under specification. Under specification in pod selectors we are going to match the label which is app colon backend. So with this match label that the ingress traffic will be allowed. and a list of rules that allow incoming traffic from front end. So from front end to a back end, basically we are going to allow the traffic here on port 80. So let me create this file. And let me save it. Now let's do one thing. Let me apply this file as well. kubectl apply hyphen f and a file name. Okay, now let's clear the screen. Now let's again do a curl from front end to back end, and now we have allowed the traffic from front end to a back end, which is ingress traffic we have allowed. So let's see what happened. So actually this will not work because we have allowed a one-way traffic. Ideally we should allow a two-way traffic, because the traffic from front end to a back end will be a egress traffic, and back end to a front end will be a ingress traffic. So if I go back to my a presentation, so here the traffic from front end to backend will be egress, because from front end the traffic is going out. So this will be a egress traffic, and from backend the traffic is coming to a front end, which is ingress. So what we did, we have enabled the ingress traffic from backend to front end, but we have not allowed a egress traffic, because the packet should be received on front end as well, then only we will get a response. So here I have also mentioned allow front end to a backend, which opened the door into a backend, which is ingress, but the door out of front end, which is ingress, is still locked. So when front end try to talk to backend, it get stuck at its own door, because request will be failed. So because this is the egress traffic which is going to the backend, and we have allowed only this traffic, but this traffic, the first one, is still not allowed. So for that we have to allow a front end egress rule or egress network policies, then only these pods can communicate with each other. So what we will do, let me go to my documentation. Let's wait what the response we will get as part of this testing. So now you can see we are getting again a same response, failed to connect to the backend port 80 after this milliseconds, could not connect to the servers. So now what we have to do, we have to allow a egress traffic from the front end, so the traffic will be bidirectional. So now let me close this file and let me go to my documentation, and here allow front end egress ml file. So here what we are going to do, so here we are going to use a front end as a match label, and here we have just changed the policy type, which is egress, and again match label will be backend. If so, let me copy this file name. Now let me apply this file. Okay, so this is completed. Now let's verify. So now you can see we are able to see a response again, welcome to the NGNX homepage. And if I will do, instead of front end, let me do here backend, and here let me do a front end. Actually this will not work. Let me see. Why it will not work? Because we have not allowed a egress traffic from backend to front end. We have just allowed a egress traffic from front end to back end. So now the traffic is not like, basically now we are going to a vice versa. Earlier we were using front end to back end, now we are testing back end to front end, but we have not allowed a network policies between back end to front end. So if you want to test of back end to front end as well, again you have to create two more manifest files which will allow ingress and ingress traffic from back end to front end. So that's how basically we use network policies in real time environment or in your production environment to restrict the communications, because in real time we don't want all the ports to communicate each other due to a security concerns, and that is also not a best practice. So to achieve this we generally use a network policies. I hope it's clear. In case if you have any doubts, you can ping me over comments. So all the files you will have in a GitHub link. That link will be in a description box of the video. So that's all for today. See you next video. Thank you so much.